Another great question from you all is, what is the correlation between the Kw with Ka and Kb? So what is Kw actually? Is an ion production constant, where you know that Kw is concentration of H plus times concentration of OH minus, whereby the value of Kw is a constant value, which is 1 times 10 to the power of negative 14. So now, what is the connection between this Kw with your Ka and Kb? So it should have a connection. So I'm going to explain further about this in the following video. Alright, now I'm going to explain to you what is the correlation between Ka and Kb. So I'm going to explain to you about these two things, the Kb and also the Ka. It's actually from the same substance, so you have NH3 around here and NH3 around here. So it depends on what is your actual reactant to make. If you have the NH3, you will form NH4 plus. If you start with NH4 plus, definitely you will create NH3. Alright, so what is the correlation between this Ka and Kb? Both of these is not a strong acid or a strong base, so it will have the value of Ka and Kb. And how you can correlate this with the value of Kw. So in order for you to have a Kw, means that you need to make sure that this reaction, these two reactions, will create the auto-ionization of water. So it will create, somehow it will become because the formula for Kw is the concentration of OH minus times concentration of H plus, or the hydroxonium H3O plus. So let us do this. So when you want to calculate your Kb or Ka, is you look at whatever in the reactant divided by whatever in the product, right? So and you have to bear in mind that when you calculate your Ka or Kb, you do not use the value of H2O. H2O will not be involved in the calculation of Ka or the Kb. So I'm going to start with the Kb. So if you want to calculate the Kb, it's going to be NH4 times OH minus divided by this one, NH3, right? Okay, so let's say if this one I multiply with the Ka, so your Ka is H3O plus times NH3 divided by NH4 plus. So what shall you get? Right, so from here, because it's multiplication, right? So this is NH3 and this is NH3. Okay, that's it. So you have NH4 plus, you have NH4 plus. Okay, so at the end, because you have already slashed that out, so you should get, if you multiply the Ka and Kb all together, you will get the auto-ionization of water. So OH minus times H3O plus, the hydroxonium, is actually equivalent to the Kw. So if you don't believe me, you can use your calculator and do 5.6 times 10 to the power of negative 10 times 1.8 times 10 to the power of negative 5. You should get equivalent to 1.0 times 10 to the power of negative 14. Alright, moving on to the fifth question. In the fifth question, you asked me, how do you determine whether the product of the dissociation should be H3O plus, which is the hydroxonium, or just the H plus? Okay, this is very simple. You need to look at the question given to you on the substance or the reactant that is play a role inside that particular reaction. So if your reactant is in liquid form, it means that most probably your results should be in H plus instead of H3O plus. But if it's an aqueous solution, so the definition of an aqueous solution is that particular substance or like a powder is going to be mixed together or turned into liquid by the addition of water. Therefore, you should get the product will be H3O plus, which is the hydroxonium. So I'm going to give an example about this in the following video. Okay, let's get started with this. So when you want to know the product of dissociation, just like I have explained just now, you need to look at the state of matter. So like this, you have CH3COOH for both example. So one is in the liquid form and the other one is in the aqueous form. So remember, if it is in the liquid form, it means that this CH3COOH is being melted. So no additional of water or moisture is being added to this one. So when it dissociates, it becomes CH3COOH. Because this is in liquid form, you do not need to add any water to it. So it will dissociate into CH3COO minus plus H plus. Right, this is the balance equation. But if it's in aqueous form, remember, if it's an aqueous form, you will need to add water to it. So the product will be slightly different. So you will get CH3COOH plus water. So the product will be slightly different as the one above here. So this one should always be the same, CH3COO minus plus, instead of H plus you will get H3O plus because of the additional of water over here. So you will have extra hydrogen, and then you will get H3O plus, which is the hydroxonium. Okay, moving on to an example of a base. So for example, you have NH3. You know that this is a base, so if it dissociates, definitely it will create the OH minus. So when from NH3, definitely it will create NH4 plus, right? So how else can you get the OH if you don't add water to it? So definitely this one you need to add H2O. So by additional of the H2O, so from H2O here you will get the H plus and the OH minus. So the OH minus come here and the H plus will add to the NH3. It created the NH4 plus. Alright, question number 6, still on the strong acid and the weak acid. So one of you did ask, so how do we consider it's a strong acid? So when it's a strong acid, the main thing that you need to remember is that it will dissociate completely. So it becomes a strong electrolyte. So it can be either a strong acid or a strong base. So how are you going to look at things? So basically, if it's covalent bond like protein, it will never dissociate completely. So we can never expect protein to be strong acid or strong base. So but for example, if you have like ionic bonding like HF, you know that H plus and then F minus, it will have ionic bonding, right? So although this is an ionic bonding, but this is considered as a weak acid. Do you know why? So because the fluorine is bonded strongly with your hydrogen. So when it bonded strongly with the hydrogen, it will not dissociate completely because the bond is so strong. And that's another example, like a substrate that have a combination of ionic and also covalent bonding, which like for example sodium carbonate. So in sodium carbonate, instead of just ionic bonding, it will have a covalent bonding, which is the C double bond O and the CO. But we still consider this sodium carbonate as a strong acid. So if you want to look at things as a strong acid or a weak acid by looking at the bondage is not literally correct. So like I have explained before, if you want to make sure or ensure that that particular substance or acid is strong or weak acid, you should always look at the value of the Ka or the value of the pKa. So if it's the pKa is lower than -1, it will definitely be a strong acid as opposed to weak acid. Moving on to question number 7. So you did ask me, will the pH of a substance change if you do a dilution? So this will definitely change. So for example, if I'm going to give you a strong acid, because when in terms of strong acid, the concentration of acid itself is equivalent to the concentration of the H+. So if you dilute a strong acid, say for example at first the molarity of the strong acid is 2 molar, and then you dilute it and it became 1 molar. If you can calculate back the pH for the one that have 2 molar of, for example, HCl. 2 molar HCl, we have a pH of -0.3011, and if you dilute it until it becomes 1 molar, the pH will be 0. So it will differ in terms of pH. Alright, moving on. And most of you did ask, can you get a negative value of pH? Yes, definitely, because it depends on the concentration of H+. So if you have, like for example just now, if the H+, the concentration of your substance or your acid is 2, like 2 molar, so definitely your pH will be -0.3011. So but if you use a machine or a pH meter to check it, maybe they will not they will tell you that something is wrong, because we assume, as a scientist, we assume if it have like very high concentration, perhaps a part of the proton or the H+ will be bonded strongly and it will not dissociate completely, so it will not give the negative value. But theoretically, yes, it is possible to have a negative value for the pH.